All right, so you're doing your embedded assessment, and it looks a little different than mine because I typed it up for you, but it's also in your book. So if something happens and we run out of copies, you mess up, you can also do the one in your book. Or if you missed class today. All right, so the first part, memory cards are used in many devices. You probably own several devices that use these cards to hold photos, music, or documents. The table below shows the number of songs, the minutes of video, and the number of photos that different size memory cards can hold. So then it tells us over here, megabytes is going to be MB, gigabytes is GB, and then 1024 megabytes equals 1 gigabyte. All right. I'm going to go ahead and scratch this out because I believe you do not have number 2 in yours. Okay, number 1. The data in the table relating memory card size to the number of songs the card can hold represents a function. Explain why this is true. So it's already telling us it's a function. We just have to say why it is. All right. So our textbook answer is going to tell us that the data relating to memory card size to the number of songs represents a function, since for every number representing the size of the memory card, there is only one number of songs in the memory card holds. So what that basically means is when we look at this guy, all right, we're looking at this. We know that if our x's repeat, they're cheating, then it can't be a function because for every input, there's only one output. It's saying our input is going to be the size of the memory. And the reason that we know that is because it comes first, memory card size. All right, so we're looking at this column here and we're seeing if we see any repeats. So we've got 32, 64, 128, 256, 512, 1 gigabyte, and 2 gigabyte. All right, so we see that it doesn't repeat. So we'll just write up here. And mine's going to look a little weird because I don't have as much space. That's why I retyped it for you guys so you actually had space to write. So it is a function because, I'm going to change my color, because there is one input for every output. And you don't have to have this exact thing. You could have said something like the x's aren't cheating. You could have said that I don't see any x's that repeat. It doesn't matter, but the main idea is that you notice here, these are all different numbers, okay? All right, number 3, graph the relationship between the size of memory card and the minutes the memory card holds. So I'm going to erase this blue right here because now we are going to be looking at, oh, I have my eraser on still. We're going to be looking at the size of the memory card and then the minutes of video. All right. So first thing we're going to do is going to figure out which one's our X. Since it says size of the memory card first, that's telling us that the memory card is our X. All right. The minute of video, since it's second, that's going to be our Y. So we're just going to go over and label our axes. All right. So this first one on the bottom, we'll just write memory card. And then on the side, we're going to write video, minutes of video. You're not going to see mine because my screen doesn't go over that much. So it's going to be super tiny. So minutes of video should be on that side. I'm going to go ahead and erase it because you won't see my labels if I leave it on there, but make sure you have minutes of video written over there. Okay, I'm going to see if I can move this really quick. We have a little bit more space. All right. So we know that our memory card is kind of funky. So if we're looking at it, we see it goes up 32 here, and then 64 plus 32, I think, is 128. I'm going to check. Actually, there's no way that 64 plus 32 is 128. Miss Beacock was messing her math up. All right, 32 to 64 is plus 32. 64 to 128 is plus 64. 128 to 256 is plus 20. 128. So it's just constantly doubling. And since we don't see a pattern, we're just going to pick something to go up by that will give us a lot of good numbers to graph. I'm only going to graph a couple of them. So I'm going to go up by, I'm going to go up by, I think 500s. Actually, I'll go up by 100s. There's really no wrong way to go up. So we'll do 100, 200, 300, 400. And it's really hard to see because I picked a really bad graph. But each of these lines is worth 100, okay? And we're just going to label that all the way. Since my minutes of video goes up by, it goes from 2 to 4 to 8 to 16 to 32, I want to make sure I get a nice looking graph. So I'm just going to go up by 2s. Okay, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. All right. Let's see if I can get a couple more. 22, 24. All right, so I'm just going up by 2s. Now I'm going to actually graph that. So my first is 32 gigabytes. That's going to be between my 0 and 100 here. And I'm going to go up to 2. So I'm going to put a dot about right there. All right, my next pair is 64 and 4. So I'm going to go still in this little thing here. And I'm going to go a little bit close to 100, and then I'm going to go up to 4. All right. Now, my next one is 128. Like, having a hard time there. So I'm going to go between my 100 and 200. I'm going to be kind of in the, a little close to the 100. I'm going to go up to 8. That's about right there. Okay. Not really liking my dots. All right, next one. So I did 32, I did 64, I did 128. Next one, 16 and 256. So I'm going to go between, all right, if we remember, that's our 100, that's our 200. We're going to go between our 200 and 300, about halfway. We're going to go up to 16 and put a dot. All right, so that's 256, that's our 16. Next, we're going to do our 32 and our 512. So we're going to go over 100, 200, 300, 400, 500. It's going to be a little bit this way. We're going to go up to 32. Okay, so I got my 24 here. Looks like I'm going to have to label a little bit more. 26, 28, 30, 32. So my next one is going to be 100, 200, 300, 400, 500, and 36. Then all the way up to 32. All right, now I'm just going to connect my dots. Hopefully it'll give me a pretty nice line. This is a really tricky problem to graph because our numbers are so weird. They get really big really quickly. And as long as you have a straight line and you try to graph it, go ahead and give yourself some points for that, okay? Because it's really hard to graph. So as long as you attempted it, you're good. All right, next one. So this is going to be number 3 on your paper. How would your graph change if you were graphing the number of photos rather than the minutes of video? So instead of graphing the minutes of video, I'm going to erase that. We're going to pretend like we graphed our photos. So if we look at that, we've got 26, 52, 104, 208, 416, 832, and 1,664. So if we look, instead of going up small amounts, like this is only going from 2 to 4, we're going up 26 to 52. That's a huge amount. And instead of going from like 4 to 8, that's only going up 4. We're going from 52 to 104. So since we're having such big numbers over here, we know that it's going to increase faster because our numbers are getting bigger faster. So we're just going to say our slope would increase. Okay. I know that one's kind of difficult, but what we're really looking at here is that these numbers are getting bigger way faster than these numbers are. Okay, the next part. Number 5. So number 5 is probably going to be number 4 for you because we skipped one. Just look for the problem that actually matches this problem. All right? So state whether each of the following represents a function. So we need to remember that a function means every input has exactly one output. Okay, and if we remember, our inputs are our x's and our outputs are our y's. Okay, so we're looking at our inputs here and we're seeing if we repeat. We've got 1, 2, 4, and 8. So we have no repeats, so we can say this is a function. I'm going to go ahead and erase so I have more room. Maybe erasing. Trying to erasing. The effort is there. Nope. Alright, erasing is not going to happen. Sometimes Miss Peacock's not very good at technology, so we'll just scratch that out. Alright, so we'll put for letter A, we'll just write it down here. It is a function because every input has one output. That's what we should have for letter A, because we see that none of our x's repeat. And as long as you write something there that describes why you think it's a function, you are good. All right? It's okay if you don't have the same thing as I do. All right. So weird that my eraser's not working. Letter B. We're going to look at the vertical line test for letter B. And if you remember the vertical line test, we're just going to put our vertical line down here and see if we intersect more than one point. Okay, we got a point here and a point here. Because we have more than one point on the line, that's telling us that we have a part where x has two y's. X has one y here at -1 and one y here at 1. So because it has two y's and it can only have one, it's not a function. Okay, so we're going to say B is not a function because it does not pass the vertical line test. Oh, this is going to be weird. This is getting creative here. Vertical line test. All right. Oh, I even lost my little dash here. Okay, letter C, we look. 1 goes to 2, 2 goes to 4, 3 goes to 5, and 8 goes to 3. We don't repeat any of our numbers, so letter C is literally going to have the same answer as letter A. Okay. All right, technical difficulty, but we are on to number 6, which is probably number 5 for you. I know the numbers are all weird. Okay, so they give us function 1 and function 2. Okay, it says use a representation different from the ones given to describe each of the functions. So I kind of helped you out with that and gave you a little guidance. I am not bored with my desktop background. Thank you very much. Go away. All right. I gave you little pointers on there, but since I'm doing it from the book, the pointers aren't in there. So I'm just going to work with what I got, and I'm sure you can figure that out and how that looks on your paper. All right, so for function number 1, it is given to us as a line. So we're actually going to go over and graph it. And you have your own graph to do it. I don't, so I'm just going to do it on the same one here. We know that the number next to our x is our slope. So our slope equals 2 over 1. And our y-intercept is the other number, which is 4. So our y-intercept's our starting value, so we're going to put a point at 4. And we're going to go up 2 over 1. I'm going to do it one more time. Up 2 over 1. All right. Now I'm going to graph that. And there we go. So that's the first part. I graphed function 1. The next part is I'm going to write an equation for function 2. So my starting number here is 0. My y-intercept is 0. My slope, I'm going to use this point and this point. So I'm going to go over 1 and up 3. Okay? The up always goes on top. So we'd have 3 over 1, which is just the same as 3. Now we're going to plug that into our mx plus b equals y. You are going to have a pop quiz where I'm just going to ask you what slope-intercept form is. So make sure you memorize that before next class. So our slope is m, which is 3x. Our y-intercept is b. So plus 0 equals y. We simplify that, we just get 3x equals y, because there's no point in having plus 0. That's just saying plus nothing. All right, so this is our function 2 as an equation. All right, evaluate each function for x equals 5. That means we're just going to plug it in. So there are 2 ways we can do this, and I'm going to go ahead. All right, it's just not working again. So I'll just go ahead and show you the part where we're plugging it in. So for our y equals 2x plus 4, we're going to put the 5 where the x is. So times 5 plus 4. 2 times 5 is 10 plus 4. Then 10 plus 4 is 14. So y equals 14. For the other one, y equals 3x, we're going to put the 5 in the x spot. So 3 times 5. Multiply that and you get 15. Another way we could have done this is go to the 5 spot on our graph and go up. And unfortunately, it doesn't show us. See, look. There's no more graph. So I guess we can't check our graph. All right, letter C. Compare and contrast the 2 functions. This one's kind of a big question. So there's a bunch of things you can write here. Let's just looking at the compare. Okay, if we look at comparing, they both go up. They have, since they both go up, they both have positive slopes. All right, let's go back. I'm going to see if I can clear some of this so I have some more space. That way we can keep it on the same page. Okay. All right, so now we've got our graph there. We know that this equation is 3x equals y. All right, so for our compare, okay, they both have positive slopes. You want to get really fancy, that's called a positive correlation. You don't need to know that. That's just an extra fancy tip. We know that they both have positive domain and range. So what that means is all of our x's are positive and all of our y's are positive for this graph. The positive domain and range. They both are linear because they're both lines. All right, let's see, what else? They both are continuous. Okay, they're continuous because they're lines, they connect. Okay, and they both, let's see if we can find one more. I can't think of any more, actually. If you can come up with one more, go ahead and write it. All right, I'm going to go ahead and erase this because I need the space. Now we're going to come up with reasons why they're different. So the contrast. Okay, so first if we look at our slope, this one's 2 and this one's 3. So function 2 has a bigger slope. Actually, instead of bigger, let's use more of a math word. We'll say steeper, because if we look at our line, that's super steep. So a steeper slope. Then we can also say that function 2 intersects at the origin, and all that means is that function 2 goes through 0, 0. Okay? All right. If you come up with any other ones, you can go ahead and write them. There's a ton. I just wrote a couple. All right. Okay. All right. That is all there is for this part. So after you've checked your answers, make sure you've corrected them, turn it into the folder because it will be graded.